The regular nonagon ABCDEFGHI shares two of its vertices with the irregular hexagon AJKLMI. Show that the points HMD lie on the same straight line. So let me just draw a line from H to D. And it crosses M. We've proven it. No, we can't just do that. Now, but I will keep the line though. Let's start evaluating some angles. So this angle over here is the interior angle of a regular nonagon. And we can work that out from this formula. Yeah. So we plug the n value in, which is the number of sides. And boom. We get 7 times 180 over 9, which is 140 degrees. That's 140 degrees. And the interior angle of the hexagon, you should know, is 120 degrees. You can use this formula too, but that is some common knowledge you might want to learn if you don't know. So now we've done that, we can find the the measure of angle HIM by subtracting those two to get 20. So this teeny tiny angle is 20 degrees. Now, since this is an isosceles triangle, because this side is equal to that side, well, this side is equal to this side, but this side is also equal to this side, so these two are equal, right? They share two vertices with each other. Therefore, it has a side in common, so all these sides of the regular polygons are equal. So we have that, and we can work out this angle is 80 degrees because it's an isosceles triangle. Now we know that's 80, we know this is 60, right? Because 140 minus 80 is 60. And now you have to note that on this side of the what do you call it? On this side of the nonagon, it's 60 degrees. So on the other side, it's also 60 degrees. Because a nonagon does indeed, of course it does, have a line of symmetry like that. So all you gotta do is to whoop and you flip it over. Now, what we can do here to prove that M is on this line is something kind of weird, but you will get it now. So it's 140. This is 140 degrees. So is this, and so is that. Sum it up. And what do you get? Well, before that, how many sides does this irregular polygon have that I'm roughly highlighting in green? It's 5. It's a pentagon, right? So the interior angle sum of the pentagon is, well, it is 540, right? You can use this formula too, but then just don't divide by n and you'll be fine. Because each of the angles is 108 in a regular one. So now we know that, we can sum these values up and find if it is 540. And we get 420 plus 120, and it is 540. So that is a pentagon. That's a good thing, right? And since it's a pentagon, right, point M is on line HD. Now why? Okay, imagine point M was lower. If it were lower, then instead what would have happened is that the line, say point M is here. Point M is here, right? The line would have gone down. Well, I would have drawn it that way, but I didn't because it's not down. So then that would have happened. And if you did calculate, okay, imagine this very small and you can't see, and you thought it was a straight line, and you did calculate it, it wouldn't actually sum, because now this 60-degree angle is broader, making it more than the interior angle of a pentagon. Then you know point M is not on the line. Therefore, point M is on the line because we've proven that it sums the interior angle sum of pentagon, and I have showed you the proof, and that is our answer.